I'm going to talk a little bit about the importance of moving the DNS system onto the blockchain. I'm going to talk a little bit about how the DNS system is broken right now and why it's very important that we find a more trustworthy solution than our current set of technologies. So the domain name system is the system that turns google.com into an IP number that your computer can actually communicate with. And so every app that you use on your smartphone, every website you visit on your web browser relies on the DNS system to function as expected. And so we're going to talk a little bit about how the DNS system is being broken today and why a blockchain is a good replacement. On top of the DNS system is the certificate authority system, which is a set of over 1,000 organizations that basically say this domain name is paired to this private key or public key pair. And that is sort of the basis on which HTTPS functions. And there are 1,000 of these organizations. Most of your browsers and devices trust all of them. And so anyone can go and any one of those 1,000 organizations could go and issue a certificate for, let's say, google.com. So the last year, the kind of theoretical attacks against the domain name system have become much more real. It used to be that maybe you were sitting in a coffee shop using the public Wi-Fi and somebody would intercept or spoof the DNS server for the ISP that everybody was on and redirect your traffic for banking sites or whatnot. But the last week or two have been about nation-state attacks on the DNS system. So on March 20th, the Turkish government instructed all of the ISPs in the country to redirect the DNS entry for twitter.com. The reason they did this is that twitter.com was where a corruption scandal in Turkey was spreading. So you can kind of imagine how this is going to look like in the future. Whether there's a riot in your town and you're trying to upload a video of something to google.com. The domain name system, because there's no cryptographic trust in what entry maps to what, that is the easiest place for an authoritarian regime or just a scared government or your internet service provider to screw with how your internet works. And so it doesn't matter whether or not how decentralized and peer-to-peer the rest of your systems are. If the domain name system doesn't work, you have a real problem connecting and using the internet. The certificate authority system is based on cryptography, but this system of trust is easily broken. Google, outside of the sort of normal certificate authority system, they track who is issuing certificates for google.com for everybody with a Chrome browser. So every time you use the internet with the Chrome browser, they just kind of track who issued that certificate and they report back to the Google server. And Google discovered that the French government on one of their internal networks had actually told the French certificate authority, issue a false google.com certificate, and on this network we will serve that certificate and it allows us to monitor what everybody does on their Gmail account, etc. So the point is these attacks have become very real world, very common, and very cheap. And so that's the reality of this fundamental piece of infrastructure that trillions of dollars of global commerce rely on is fundamentally insecure, fundamentally broken, and being exploited in the real world. So cryptography is clearly the solution to this problem. So we've kind of gone through and seen sort of centralized trust approaches to adding cryptography to the domain name system. So one of the ideas that has been floated has been this idea of DNSSEC, which is the idea is somebody we trust. It's not clear who, but some trustworthy party. We have them sign all of the entries in the DNS server system, and then your iPhone, etc., can verify that the DNS data that it's getting was signed with that trusted key. This has been enormously unsuccessful. Essentially no entries, it's like some fraction of a percent in the DNS servers are signed today. So that's one problem. The other, so that's a great idea to make the data cryptographically verifiable. It's not been a successful idea. The next, sort of in parallel, so what happened in Turkey was first they shut off all of the DNS servers inside the country. So then, there were these well-known pictures of people spray painting the addresses for like Google DNS on the side of buildings in Istanbul. And what the government in Turkey did is then started IP address spoofing those IP addresses for 8.8.8 and 8.8.4.4. So what that ended up, so the idea of having something like DNS crypt is to make that at least significantly more difficult to do. Basically, your name server has a cryptographic key, you look for that cryptographic key and you encrypt both what you query, what URLs you query from that, so data traffic between you and that server are encrypted. So the idea of this is also prevents the global passive attacker from monitoring what everybody is doing on the internet by just watching their DNS queries. And then the final idea of how to make this better is so we had that problem in France about a government issuing a false or a fraudulent trusted SSL certificate. So the idea of certificate transparency is that every time we publish, you set up HTTPS on your website, there's the certificate authority actually publishes in some public place what certificate that they published, the keys associated with, and everything. So there's some place where the SSL system as a whole can be audited theoretically by some sort of client device, but nobody's really sure how to do that. So none of these ideas have been very successful. None of them are very widely deployed, and so we're stuck in this state of kind of rotting the one key piece of the infrastructure with no cryptography in the practical world and is out there for people to exploit. So kind of the logical thing to do is there is an extent to which the blockchain can encapsulate all of the ideas in the proposals for improving the security and verifiability and trustworthiness of the domain name system. So kind of the way I think of a blockchain is a system for enforcing invariants. And so what Bitcoin does is their transaction system enforces the invariants, that there's a constant amount of value in the system, that transaction inputs and outputs are bound together, and that all transactions are bound to at least one public key. So what do you need to enforce to make a domain name system on the blockchain? You've got, to begin with, 3 characteristics. You've got the name has to be unique. You don't want multiple people registering, Ethereum.com or whatever. You could have, you want to have one public key associated with each record so that you can verify the signatures of the data. You can set up SSL connections, etc. And you want to guarantee that on the blockchain, it's publicly known when the private key associated with a piece of data changes. So it's more or less abundantly clear to me that Ethereum meets the characteristics and can enforce this set of invariants. The way Namecoin is implemented is they do sort of a lookup on a local data store that is very analogous to the sort of the hash table function inside of Ethereum for a contract data store. The sort of basic transaction semantics can enforce the bindings between a wallet address and a record. And for the same reason, the transaction semantics can enforce moving a wallet, a given URL or a given name to another record. That's not really the hard part, because Ethereum was really conceived after Namecoin sort of got started. This is sort of built into the use case of what Ethereum was designed around. And sort of in my opinion, whatever blockchain 2.0 technology you're looking at, the DNS use case is so necessary, it's so obvious, and it's so ready for mass adoption because of the just massive dissatisfaction with the current DNS system among basically everybody who's a stakeholder in the internet, maybe except for authoritarian nation states. It's a good test case. I think the real challenge for something like Ethereum is not in the can you enforce the transaction semantics. It's can you allocate costs within those computations to the right parties. Because the accounting has to be really complicated. You want reads and writes to the system to be, or reads of the system to be free. You want to encourage people to verify their domain names that they are getting served on the blockchain. You want to encourage multi-party trust, so you don't have like one central group of people caching every DNS entry that's stored on the blockchain and serving it to the rest of the world, because that just recreates the current system. So you want reads to be really cheap or free to the system. But you want writes to be the place where everybody gets compensated. And so you're either going to have to create a software architecture that accomplishes that in a distributed, or you're going to have to create a fairly sophisticated accounting scheme to amortize the cost of serving read and verification requests on the Ethereum network on top of the payments from the right. You look like you have a question.
But I'm just kind of confused. I mean, the whole point of the blockchain is that it's available for anybody to look at. So isn't the blockchain by default free? I mean, this data or the data storage is.
So this comes back to the question of, so the contract data store, okay, is a question of, so you have to pay Ethereum for it, and it's somewhat unclear to me from the spec whether or not it's fully replicated to every single node in the network.
Well, at least let's just, yes, I think is the answer.
Nodes, I think so.
I mean, there have been discussion about doing some fancy stuff in the future, but I think for now, you can assume that every node gets the full thing.
Well, okay, so let's hypothetically you have your full node. It's got the whole thing. Now you're going to ask the full node to essentially compute. So it's going to be doing all of its normal mining work. You're also asking it to do lookups within the blockchain, essentially for free, in order to serve these.
Yeah. Locally, it's a bit of a stretch on a smartphone, right?
Exactly. So no, your smartphone wouldn't necessarily need to be mining. All it would need to do is to have the
storage requirements of running a full node are not conceivable on the majority, are not practical on most devices.
So what's the word? What is SPV? What are these SPV clients in Bitcoin? I forget what that stands for,
Simple verification.
but isn't the idea that you can have, you may not need to be a full node, you may not to be a mining node in order to have the data associated with the blockchain. You're just verifying.
It's a bit different.
I'm just trying to figure out why it's a problem to that.
So
the verifying,
okay, let's
the
compare
reads.
a little bit about the way Namecoin works. So in Namecoin, this is all implicit, okay? So you're not being charged for operations on the blockchain. So they basically set up the way their executable works so that reads to the data store are always free, and verification of the data store is always free, and writes are the only thing that cost their internal currency. Ethereum has the implicit thing, which is anytime you transact with the block store, you're supposed to be paying it either.
Wait, why are we using Ethereum rather than Namecoin again?
I think that is a separate question. the question, I mean, so what is the problem with, or the questions, so Namecoin has both botched their go-to-market strategy, which is what creates opportunities for alternative implementations. The second question is the appeal of doing this on a general purpose system, because it's core internet infrastructure, somewhat appealing rather than just saying, okay, we're going to build another specialized system, Namecoin 2.0, to solve the problem.
Zaki, we talked offline about this. So the DNS system, whatever, you've not mentioned ICANN once in your discussion in namespace. So there are these organizations that are doing this.
Sure.
So let's talk a little bit about the people that are movers and shakers in this area. And
So
how they can,
you've got basically,
because I'll get them on board, but yeah.
you've got basically, I think there's actually a very effective go-to-market strategy that, so Namecoin's go-to-market strategy was they wanted to balance between rewarding early adopters and on the at the same time sort of supporting currently existing property rights. So basically what they did was they said, okay, we're going to start out and make registrations in 2011 or so, really expensive, and then it's going to fall towards some current level where it's now relatively cheap to register. And basically nobody was paying any attention when they initially launched, and all of the existing property rights, so like, so they have this notion of a .bit domain name, and so like twitter.bit is owned by some like random wallet address rather than Twitter. So it's abundantly clear that what you want to do in terms of actually bringing these systems to market is you pre-mine and you pre-set up in your system the existing set of property rights holders. So you go and you say, okay, here's a private key that is associated with Google's let's say you only want to use a subset of the domain name space. So here's Google's .bit address. Here's Twitter's .bit. So you get the existing property rights holders to buy into your system. When you look at, so that's one constituency that cares a lot about bringing, that you can get on board. The mobile security, like the mobile security teams, the browser security teams of all of the major internet vendors, Mozilla, Firefox, if you want to see what they complain about the most, what the thing they feel the most uncomfortable about when they say that they are delivering their core mission, which is a secure internet, it's the DNS system. The DNS system is the thing that they're asked to secure that they don't have remotely the tools to do so. And so there's a constituency there that wants to replace it. And I think the constituency that would be most reluctant to replace it are the nation states. But they're just one of a number of stakeholders in replacing a system like this.
Related to this previous question, search engines. So in case of Namecoin didn't work out well, why would Google query this system? I mean, search this system and index it?
So there is a buy-in on when it comes to internet companies. They have an enormous amount of wealth and business associated with the notion of a trustworthy internet. And the domain name system, I think, I've been trying to make the point, is fundamentally untrustworthy. And basically there were, 10 million Twitter users in Turkey who were suddenly made very aware of the fact that the domain name system is untrustworthy. And every time that there's a censorship event somewhere in the world, or there's a compromise in the domain name system, you're adding to the population of people who are being taught not to trust the internet. And if you look at every internet company, they have a long-term interest in creating a trustworthy internet. And that's why the blockchain is a very appealing technology to them to get on board with, if you don't screw up the go-to-market the way Namecoin did.
When you say to them, what knowledge do you have that they, want this to be a blockchain-based technology?
I know, well, okay, so, you watch the Twitter feeds and you talk to anybody in the security teams of the big internet companies, and they are all kind of eyeing Namecoin kind of out of the corner of their eye because they're Because this is the thing that they're most uncomfortable about. The thing that that people who practice security for a living are most uncomfortable about the internet is the DNS system.
Well, no, you already said that, and I understand that, but I guess the question is, do they actually want it to be a blockchain-based technology, even if they recognize all the flaws in the current system? Is that really something that's
Yeah,
appealing
what's
to them?
Kaminsky saying about blockchain?
I don't know what Kaminsky's saying about it, but I watch I watch the papers that get published by Electronic Frontier Foundation. Like most of the people who are serious in the security are thinking about blockchains as a solution to this problem.
So, I mean, you're pushing kind of for a complete overhaul of the DNS. So an alternative is that you don't try to go after Google immediately. You just set up a little bit of a separate DNS that only serves some subdomain.
So-
Do you think that's possible? Maybe that's just completely not possible.
That's sort of what Namecoin has tried to do. I think.
But what's the problem with that?
I think their biggest mistake is just not honoring existing property rights.
Well, I mean, but if you separate, but if you just say that you just set up your own top level domain.
Yes, so they've been trying to set up they set up .bit. Like you can point your DNS at a result, or that'll resolve .bit to the Namecoin address holders.
But is that, I mean, so
imagine, okay, so here's your go-to-market strategy, okay? You set up, you have this infrastructure built out. You've got enough of the pieces of it that somebody who is in a somewhat restricted environment can now verify domain name addresses and certificates. Every time one of these censorship events happens, there's going to be some company out there that is going to be looking for the opportunity to continue to reach their customers that they can no longer reach. So if you had Twitter.bit all ready to go, and Turkey happened, because we taught millions of people in Turkey during this last censorship event about Tor. We taught millions of people in Turkey about all public DNS servers. People, when censorship events happen, they are looking for alternative solutions, and those alternative solutions eventually get mainstreamed if they're good enough.
So you think it actually is possible, for example, for a new DNS system to be only on a separate
I think
TLD?
it'll probably start out that way, but I think if you honor existing property rights, there are going to be business cases for the people who are the existing property rights holders to buy into your thing just to reach their customers.
This might not be ideal, but would it be possible to set up an existing like a DNS server that interacts with the existing DNS system and basically serves up this blockchain?
Yeah.
It's like either extent you just point your DNS server towards this one that addresses the blockchain.
You can do that, and that's kind of it. But if you do that, you're not. So if you do that, you basically have to wrap the entire past proposal section with, like, it's a way. You could think of it as a way of bootstrapping all of this stuff, like, which is part of the problem with all of this stuff. Like, we don't know how to bootstrap it.
I'm just saying it'd be a nice transition.
Yeah. I think there's a variety of opportunities. I think one of the reasons why, I think this is under-recognized in the cryptocurrency space as the scale of what this opportunity is and how badly broken this existing system is. Like, the existing system, we all rely on it. The last round of this in the late 90s of like domain registrars and CAs, like that generated billions and billions of dollars of acquisitions. Like, huge amount of wealth. Like, I mean, that's where Mark Shuttleworth got his $1 billion to create Ubuntu. I mean,
what happened? What created this $1 billion?
The last time that this system shook itself out, when we standardized around the CA system and the way that we standardized around the domain name registry system, billions of dollars of acquisitions during the consolidation phase of that. Like, enormous wealth was generated by this, and the current system is rotting, and I think it's a great idea to replace it.
So trying to be constructive for a change. What if you took the airdrop concept like they did with Lorcoin?
Yeah.
This sort of grace period where your Ethereum resolvers or whatever are reaching out to the normal internet and resolving the pass through there too.
Yeah.
Get enough people on your system, and it's not considered fully secure or fully decentralized until this sort of airdrop ends, at which point people have to start paying for resolutions.
Yeah.
Bigger companies involved. Have you considered that at all?
I mean, I come at this from the point of view of an activist. Like, what I am coming at this from is somebody needs to build a secure internet because the current internet is broken.
Yeah.
And so I think there's a variety of ways of thinking about how you get to market. I don't think the fact that Namecoin hasn't taken off is an existence proof of the fact that this idea doesn't work. I think it's more evidence that if you screw up how you go to market and how you think about property rights, and especially if you don't honor the existing set of property rights, you're kind of pigeonholing yourself into like the backwater of the internet.
But were you actually referring to bootstrapping a secure DNS there? Is that what you're talking about?
Yeah, sort of a reverse like airdrop. So where you hit a point and it's encoded in Ethereum or whatever is this date hits, we're going to switch over to secure mode, and after this point you have to pay for that.
Yeah.
Right.
So you gain the popularity, you give away.
So I think there's basically what you would do is you would be honoring updates. So like you could honor the entire existing system.
Right.
You would honor updates from the existing system to a certain point, and at that point, you say if you want updates on our DNS resolvers, now you've got to pay in Ethereum.
Yeah, and here's your keys, by the way.
Yeah.
You can sign your own.
Yeah.
Is the idea that you would have the entire DNS namespace in a block?
I think that is almost inevitable at this point. It's just a question of who does it and who makes the money.
So .com's like what, 4 gigs compressed, right?
Yeah.
It's a bit heavy when you put all the minor in.
Well, and so this is but part of the sort of Ethereum use case is the idea of much larger data stores than that. Like the idea of backing up your computer on the blockchain. So I think it's if you can't. So I think part of my point was if you can't do this, you don't have a blockchain 2.0.
Well, so there's like a completely different way of doing it, and that doesn't necessarily require going through Google and all them else, and it really depends on the sort of how motivated the users are. So you said, in this particular shutdown that millions of people started using Tor or learned about Tor in Turkey, which I doubt because there aren't millions of people in the United States who really understand how Tor works or use it. But if you could, and this is really a question kind of how motivated those users are, get them to sign up for an alternative browser package or something else and download it, and then you could spin up on top of Ethereum additional clients. So you're running Alice 0, and then you run the DNS client, and then you're actually connecting to the actual Namecoin-esque topic, thing, which actually itself incentivizes the people via the contract to run the alternative client. Yep. Then you can run a bootstrap distributed DNS network, and then have the clients actually connect to those, and then do that, which is probably a lot better strategically if you have enough motivated users, of course, than trying to go through the current ladder structure.
So right now we went during this whole you can look at the Tor usage graph for Turkey. It goes from less than 10,000 users prior to this to the daily connects are now above 50,000, so you had a 5-fold increase in a couple of days, and you've seen somewhere in the neighborhood of 1 million installs.
That's impressive. That's really impressive.
What my point is this was not a one-off. That this has been coming for a long time. It's going to get worse, not better. That if you're a government and you don't have the money to invest in a great firewall of China or the NSA's quantum system where you can do session interruption, this is how you censor the internet, because you don't want to maintain IP whitelists and blacklists, because that's so expensive that you might as well build yourself a great firewall.
Did you actually have some more slides? I wasn't certain if we got quite to the end.
Yeah, I think so. I think the other point is that the Namecoin folks have built out a lot of this infrastructure. The big piece that's missing is doing TLS verification. They've got a DNS lookup system and a proxy system that feeds off of a blockchain. that relies on Namecoin's remote procedure call layer, but that's relatively easy to either remove or proxy or something like that. Doing TLS signatures, TLS is the SSL, HTTPS stuff on a blockchain is building a reference implementation. That would be a lot of work. It would be the kind of thing that you'd probably want to get like investors and invest some actual money on instead of having a bunch of people who are just kind of running around doing this as a hobby. Because TLS is hard, as Apple has learned.
One thing you could try, instead of trying to do all of .com, let's say, even in the 6-month time frame, just focus on anything that's currently censored or has a history of being either censored, spoofed, or man in the middle. Just those sites, and you have a smaller.
The other people, so Tor has their .onion addresses, which are essentially they're hashes of public keys, and so they're unintelligible. And one of the other applications is Tor is really looking very closely at including some sort of Namecoin-like client in their browser bundle, just to resolve .onion addresses.
Well, a couple of things. One, when you talked about Namecoin, you said you made sort of two cases against sort of why I think that's something a little bit different than Namecoin. One is the go-to-market strategy.
Yeah.
So we can just sort of manipulate that and pass it in. And the other was this question of whether or not it's better to have a dedicated blockchain or a general blockchain. And I'm kind of wondering, it seems to me like the dedicated blockchain has a strong, for this application solution, has a very significant advantage, which is that the size of the DNS system is maybe over a few gigabytes, maybe 4 or 10, something like that. Gigabytes not really huge, whereas a general purpose blockchain is going to be large. And thinking about this problem, it seems like maybe the easiest way to think of it isn't to think about replacing the DNS system, but it's replacing a much older system that we used to use for those host files.
Yeah.
And to think of a DNS system as just a distributed host file, and the blockchain is just one host file and be updated via these cryptographic protocols.
Yeah. No, I think that's like a very legitimate way of thinking about the problem.
So we're actually going to record this. Could you summarize that briefly for us?
Yeah. So basically what he was suggesting is there are appealing aspects to having a dedicated client and a dedicated blockchain for doing DNS. And that's the argument against Ethereum. And that aspect of it is that basically a few gigabytes may be very cheap on a lot of machines. And we've had this system before the DNS system, which was called the host file system. It's how the internet worked before DNS was invented, which is there was a file that everybody kept on their, everybody with an internet account, who could connect to the internet, kept a file on their computer which mapped between IP addresses and domain names just for their computer, and that's what their browser or whatever looked up against, their internet tools. And
that was like awesome, by the way.
Everybody has it.
Yeah, I mean, I still have a host file. I still have my host file for my internal company network. That's how I do it. DNS is a pain in the ass to set up. So host files are not bad, and they kind of got replaced by this centralized trust system, and maybe that's a cryptographically signed host file is the future.
Isn't that a regression? I'm going to bring up the counterpoint. Like, if we want to go distributed and everybody has a copy and it's all backed up and it's all signed and double distributed, and then we're like, well, everybody needs a copy of the blockchain machine. Like, didn't we just return it?
Yeah, no, neither one of them solves the whole problem because if gigabytes are cheap for you and bandwidth is cheap for you, it's probably in your interest to replicate the entire domain name system.
The battery life is expensive.
But if you're on a mobile device, if gigabytes are expensive for you, now you run into all of the thin client problems. And solving that thin client problem is like an interesting aspect of this whole story.
And if you're a consumer in Turkey, you really got no idea what these guys are talking about.
Yeah, but you can educate. I mean, this is what happens. Is every single time people can't get to the website that they want. Whether you're the several 150 million people in Pakistan who can't get to YouTube.com, or you're the 10 million Twitter users who didn't get to Twitter, and you suddenly have something like that, a consumer product taken away from you, you want to know why and how you get it back.
The objective is to keep this
Yeah.
Okay, guys, I think that was wonderful. Let's turn it back.